Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 13 of JEE Mains 2016 physics paper. So let us solve question number 13. Hello students, let us solve this question number 13 of JEE Mains 2016. The question is, a combination of capacitors is set up as shown in figure. There are 1, 2, 3, 4 capacitors. These are in parallel. This is with series and they are in parallel with 2 microfarad capacitor. The magnitude of the electric field due to a point charge Q, there is a point charge Q. The magnitude of electric field due to a point charge Q, what is the charge? Having a charge equal to the sum of the charges on 4 microfarad, this one, 9 microfarad capacitor, this one. So whatever the charge that will be stored in 4 microfarad capacitor and 9 microfarad capacitors, the sum of those two charges are placed here as a point charge. So this point charge is basically the charge on the capacitor of 4 microfarad plus the charge on 9 microfarad capacitor, and you have to find the electric field due to the point charge, which is the combination of these two charges at a point distance of 30 meter from it. So at a distance of 30 meter we have to find the value of electric field, and how much is that electric field that we have to find. So to solve this, we have to first find how much charge that will be stored in 4 microfarad capacitor and 9 microfarad capacitors. So this is a very simple question because 8 volt is there. So this is in parallel. This is these two combinations, this one and this one, they are in parallel. So across 2 microfarad we have got 8 volt, and also across this combination of above we have also got the potential difference of 8 volt. So there is a potential difference of 8 volt in the above combination of capacitors and in the lower 2 microfarad capacitor. So what we will do is, we will draw this diagram and then connect it to a potential difference of 8 volt and see how much charge will be stored in 4 microfarad capacitors and 9 microfarad capacitors. So I'll draw that. This is 4 microfarad, this is 3 microfarad, this is 9 microfarad, and across these combinations the potential drop will be definitely 8 volt. Now what we have to do, we have to find the equivalent capacitance of this combination. So this can be reduced to a single circuit of single capacitor and a battery of 8 volt. 8 volt battery and a single capacitor C equivalent, because that is how we can find what is the charge that is stored in this capacitor. Otherwise we can also say that how out of 8 volt how much is the potential drop here. Suppose the potential difference drop here is V1 and here it is V2. You can also find the potential drop here and here. If I know the potential difference, I know the charge, because charge will be C into V. So I know the capacitance. If I know the voltage drop across here, I know the charge over there. Similarly, if I know the potential drop here, because these two are in parallel, so same drop will be here and there. Then if I know V2, I can multiply that with 9 microfarad capacitor. CV, that will give me the charge over here. So this charge over here and this charge over here, I will add up. So this way you can find the equivalent and then solve it, or you can directly distribute the potential difference. So we can do both way. Let us first solve this way by dividing the potential across the capacitors. Now this is 4 microfarad, and this is the combination of these two is how much microfarad? Now this is 4 microfarad, this one, across which the potential drop is supposed to be V1, and the combination of these two here, the equivalent capacitance, these two are in parallel, so 9 plus this 12, so this is 12 microfarad. Across this the potential drop is V2. Now out of 8, how much will be the drop here and how much will be the drop there? Because we know that Q is CV, and in series the charge is same, so this is same, so CV is constant. That means V is inversely proportional to C, this relation. That means the voltage drop will be reciprocal of the capacitance. So the voltage drop here will not be based on directly proportional, is not directly proportional to the capacitance of this, but depends on this one. So from this we know that V1 C1 is V2 C2. You can see that C1 V1 C2 V2. So from here, if I want to find the potential drop V1, then it is V2 C2 or C1, or I can write the equivalent of this and I can drop the potential. So in any way it can divide the capacitance voltage. Now I will divide this way, that V is inversely proportional to C, so I'll write the capacitance of the second capacitor. If I want potential drop here, I'll write the capacitance of other capacitor divided by the total capacitance into the potential, that is 8 volt. So what I'm doing is, the V1 is actually the other capacitance, that is I call this C2. So this is C2 divided by, I am calling this C1, this is C2, so capacitance of other capacitor, that is here. If you want drop here, you see the other capacitor, divided by the total capacitance 4 plus 12, that is 16, divided by C1 plus C2 into the total voltage that has to be dropped across the two, that is 8 volt. This formula I can apply. C2 is 12 divided by C1 plus C2, that is 12 plus 4, and V is 8. So this comes out to be 12 divided by 16 into 8. 8 2 is 16, 2 6 is 4, so 6 volt. 6 volt will be dropped here, so this comes out to be 6 volt. So out of 8, if this is 6 volt, this will be 2 volt. This has to be distributed, so this has to be 2 volt. If this is 2 volt, then this also has to be 2 volt here, because they are in parallel combinations. But we are not interested in this one. Our aim is to find how much charge is stored in 4 microfarad and 9 microfarad. That is what is given in the question. 4 microfarad and 9 microfarad capacitor charges you have to find. So again, to find the charges, we will use this formula. Q is CV. So this Q, I will call this as Q1, which is CV1. C is 4, V is 6, so it is 24 microcoulomb. So for this, what is Q2? Q2 will be this capacitance into the potential difference, that is 2 volt. So 9 to the 18, so it is 18 microcoulomb. So charges on Q1 and Q2 are 24 microcoulomb and 18 microcoulomb, and as we have seen, charges on 4 and Q, this is coming out to be 24 microcoulomb, and this comes out to be 18 microcoulomb. The sum of the two is 42 microcoulomb. So this 42 microcoulomb is put here. This is the point charge. This point charge is 42 microcoulomb, and you have to find the electric field at a distance d equals to this one, 30 meter. We know the formula for electric field at a distance due to a point charge is k q upon d square. K is 9 10 raised to 9. Q is this one, 42 micro, that is 10 raised to minus 6 coulomb. Microcoulomb is this much coulomb, divided by d square, that is 30 square, that is 900. This 9 and this 9 will cancel, this 0 will go up and this will become minus 8. This minus 8 and this 10 is to 8 will 9 will cancel, only 1 0 is left. So this is 4 2 and 1 0. So the answer is 420 Newton per coulomb. If you see the options, then this is the answer to this question, 420 Newton per coulomb. You can also either you divide or you can also distribute the I was talking about another method, that if I find the equivalent capacitance of these two combinations, this is 12 and this is 4 in parallel, in series, way to use that formula, we can also solve this way. Suppose that if you want to solve, this is 4 is there, this is 3 is there, and 9 is here. 934 microfarad, and we can get the equivalent of this combination, C equivalent, that comes out to be 12 and 4 in series, so it is 12 into 4 by 16. This is 4 and this is 3, this is 3 microfarad. So across this 3 microfarad, our voltage that is supplied is 8 volt. So then I can say the total charge that will be stored here is 24 microcoulomb. So out of this 24 microcoulomb, you have to distribute the, again, if this 24 will go through here, so obviously in series the charges will be same, so this 24 has to pass through here, so this will be 24 microcoulomb, and this 24 now will be divided in the two capacitors, because the total of this 24 has to pass, so this has to be 24. How that 24 is divided, how to distribute the charge when the potential is same? Again we'll use this concept, Q is equal to CV. Here V is same. If V is same, then the charge is proportional to C. Charge is proportional to C. That means if I want the charge over here, then I will write the, suppose this charge is Q2, then I will write Q2 is the capacitance of this, that is 9, divided by total capacitance is 12 into the total charge, that is this 24 is 2, so it is 18 microcoulomb. So this comes out to be 18 microcoulomb, and previously also we got 18 microcoulomb and 24 microcoulomb. So that will lead to the same answer, So this way also you can find the charges on the capacitors, or you can use that method. Either you can divide the charges, or you can get the potential drop across these two to get the charge, because the same formula you have to use. Okay, so that is how you can solve the question, and the answer to this question is 420 Newton per Coulomb, because that is the unit of electric field. Okay, thank you.